last step of the LID methodology is denormalization. Denormalize means moving fields from the other tables, i.e. the non-profile related tables, back into their related primary and or dimensional entity based on current and future business use cases. Remember this? The real-time customer profile always defines a person, their traits, and their associated behaviors with a brand or company. When we talk about the primary entity, we're talking about the core of profile. That's composed of two classes, XDM individual and XDM experience event. Dimensional entity is used to provide additional context about either the traits of that person or the behaviors. Any data that exists outside the primary or dimensional entities must be denormalized back into their parent tables. In this step of LID, we're focusing on that last statement, the data that exists outside one of these entities. Those ones we're going to have to move somewhere. So, to denormalize, you first start with identifying all the areas in your diagram that have tables to move. In the demo data model, you'll see that there are three primary areas we need to focus on. Before we start denormalizing, let's understand how you need to denormalize tables. And understand that it's a bit of an art form. There are some general guiding principles that you can follow, which I'll show you. The first rule is this. Any table in the relational model that's labeled as a D with a one-to-many cardinality, or if it's labeled as a B, is going to act as an object array in the parent table. Therefore, in the scenario of customer and customer location, you'll end up with an array of customer locations on the customer table and a direct relationship to the lookup table location. Pretty cool, huh? But as soon as you create an array with rule number 1 of denormalization, rule number 2 of denormalization immediately kicks in. Should you? Just because you can create an array doesn't mean you always should. Rule 2 states, before you denormalize a D or a B table back into an array, interrogate the data to understand how best to denormalize it back into its parent. And this is where you have 3 questions that you really should be asking yourself as a data architect in context of marketing and how they want to use this data. 1, what is the table you are denormalizing describing? 2, is all of the information in the table to denormalize relevant for marketing purposes? And 3, could the data be described in a semantically strong way, i.e. putting it into specific trait sets? So let's look at the array of customer locations for a moment. And you can see here in this table that it looks like it's describing various places maybe someone might live, have stayed, etc. What's interesting is that there's a location type within this table. Could this mean that a customer has a specific location type such as home, business, work, shipping, billing, etc.? If so, does marketing need all of those various types? What if instead all you needed to describe was the home location? Then you could model that array like so. This is really important to understand because when you model arrays, you're creating a complex piece of data that a marketing team is going to have to use at some point. Asking these questions helps you to better understand what to do with the data and if you can describe it differently. In this case, maybe the only piece of important information here is the home location. And instead of modeling it as an array, I could simply just describe it as an object called home with the various elements of that home location underneath. Moving on, let's review how you might denormalize tables related to lookup tables. Looking at the product category table, you can immediately apply denormalization rule number 1. As you know, it will turn into an array. This immediately invokes denormalization rule number 2, which says, but should you? Is there a better way to describe this array? So maybe or maybe not. In this case, there really isn't. And so leaving it as an array makes the most sense. The other side of the bridge table, though, also has a table that has a many-to-one relationship, which invokes the new rule, denormalization rule number 3. This rule states, any table in your relational model that is labeled as a D with a cardinality of many-to-one will act as either an object or just a list of fields on a parent table. So this means that before we denormalize the bridge table, we first must denormalize this table. And therefore, the category ID and name fields become part of the bridge table, which means the bridge table will become part of the array. The final array then likely only needs the category names if you drill into it, because marketing probably doesn't care about these category IDs. But again, this is open to interpretation. As a data architect, you need to be able to make these decisions and understand the consequence of these decisions. The important part is you know that you have an array of values, with some of those values coming from the category table. Now let's look at the brand table. You can follow denormalization rule number 3, which means the product brand fields just show up as fields on the product table. Therefore, when you are done, you have a product table with denormalized values of product brand name and an array of product categories with category name. Moving on to the other lookup table, you have the same pattern that you've seen before. The store type table will be denormalized using rule number 3, meaning you end up with the store table containing just the denormalized value of store type description. Again, we probably don't need to bring with the description ID along with that denormalization, because why is marketing going to use it? The store addresses table will be denormalized using rule number 1 and number 2. Without more information, there isn't much we can do about this store locations array. Even though it doesn't really make sense that the store can have many locations, there's nothing that we can tease out that says that it shouldn't be an array. So we're going to end up with an array of store addresses on the store table. This highlights another great point. The rules, while they do work in terms of how you should do something, they always need to be followed up with a question of why. In this case, I probably would go back to my data architecture team and figure out, why do we have a list of store addresses? Are we containing history? Does marketing care about all the stores? Or do they just want the latest store? But without more information, an array it is. The final result of the denormalization results in only 4 tables when you are done. I refer to this part as the IT exercise. You've denormalized all the tables back into their parent entities, but you haven't considered anything to do with the business besides once in a while asking yourself, is a marketer going to need this? But you need to consider the business requirements and their use cases when you talk about designing the real-time customer profile. There are 2 very important considerations when denormalizing data, in addition to the IT exercise. The first one is personalization. Remember, at time of personalization, only the traits and segment memberships of a profile are accessible for personalizing the content. Now, there are some exceptions to this rule if you're looking at products like Adobe Journey Optimizer. But in context of Adobe Real-Time CDP, I only have access to the traits and the segment memberships of that person. The second thing you need to think about is streaming segmentation. Remember, in this new platform, we've unlocked some net new capabilities, but those capabilities do have some guardrails. Streaming segmentation, to maintain its speed, only has access to the primary entity of the profile. Think you, the person. Who are you, and what have you done? Lookup schemas are evaluated and only used in batch segmentation use cases. They only provide additional context during batch evaluation. Therefore, if I have a use case and I think I want to make it streaming, I need to make sure that the data is inside the primary entity schemas. So now that you know this, let's consider 2 use cases that help kind of tease out how you go about applying these principles. Use case number 1 might be something as simple as send a newsletter, advertising new products that are being released, and in that newsletter you want to put the closest store name and address in your email or direct mail piece. Why? Because this personalizes and helps the consumer figure out where they can go to check out these new things. Note, in the text, the closest store name and address need to be available for personalization, but these fields were never present as traits in the individual profile schema. Where are they going to come from? Let's move on to use case 2. Let's say you have a requirement as simple as you want to suppress ads from all profiles who have bought Nike shoes in the last 24 hours. Seems like a pretty basic use case, except putting your business hat on, wouldn't it be ideal if you could suppress people from ads faster? As this functionally would optimize acquisition costs. In fact, if you think even farther back to our training scenario, Connection 5G had this exact objective. They wanted to optimize their spend. This is a perfect example of where speed optimizes spend. If I can suppress people faster from seeing ads that are no longer relevant, I'm functionally saving money, which allows me to put that money back into my acquisition strategy to go find more customers. In the use case of those Nike shoes, having the brand available at the time of the order is critical. So if you review the demo use case from the first one, you'd notice that the resulting customer schema is actually going to look something like this. The fields in blue representing the closest store would need to be added to the customer schema. In addition, the sales transaction table would need to have the product category name denormalized from the lookup table onto the sales transaction if you want to suppress purchases for acquisition ad campaigns in real time. This notes a valuable learning lesson. Lookup tables are not always going to be required. You can create them, but if you want things to run fast, they need to be on the primary entity of the profile. So after you're done applying the personalization requirement and the streaming segmentation requirements, you actually end up with a diagram that has a few more fields on two of those tables than you originally thought. And it would look something like this.